Hello, everyone, and welcome to this Firefly Atlas training video. My name is Richard Joyce, and I'm an endangered species conservation biologist with the Xerces Society for Invertebrate Conservation. I coordinate the Firefly Atlas, which is a collaborative initiative that invites both community scientists and conservation professionals to collect data on fireflies in North America. This project has a focus on imperiled and data-deficient firefly species, but we welcome survey and observation data for all fireflies in the USA and Canada. In this training video, I'm going to show you how to do a Firefly Atlas survey, including planning, filling out the data sheet, and uploading your data to the Firefly Atlas website. So let's get started. Before we do anything else, just take stock of what items you might need to acquire or gather if you already have them. It shouldn't be too many things that you need to acquire, but there are a few key items. You'll need Firefly Atlas data sheets and a writing implement. You can get these data sheets from the Firefly Atlas website under the Get Involved tab. You'll need a camera or just something to take photos. That could be a smartphone. It could be a point and shoot camera or something a little more sophisticated like a DSLR camera. You'll need a thermometer that can measure the air temperature. You'll want a headlamp with a red bulb, or at the very least, a headlamp and some red cellophane. This red filtered light preserves your night vision, and it also disturbs the firefly's behavior less than other types of light. You'll need some kind of transparent container for holding the fireflies while you photograph them after you've caught them. And I like to use clear plastic Petri dishes because they're lightweight. They have a flat surface that reduces distortion. And if they break in the field, then I don't have to deal with broken glass. In order to catch these fireflies, you'll need an insect net of some sort. And this could be a professional grade insect net like the one that you see in this photo, but it could also be something much more basic, like a butterfly net that you would get at a toy store, for example. You can still catch fireflies with a very basic net. The next couple things you'll want are specifically for taking information about flash patterns, firefly flash patterns. So a voice recorder is very helpful for this. And a voice recorder is also really great for just taking notes. You can talk, most people can talk faster than they can write. And you can also speak into a voice recorder while you're looking at fireflies rather than looking down and needing a headlamp to see what you're writing. A smartphone will have a voice recorder app built into it, so you can take the time to get to know what you have access to already. Similarly, you may want a stopwatch to take some measurements of firefly flash patterns. A stopwatch on just a digital wristwatch works pretty well. You can also use a smartphone. Now, the downside of using a smartphone is that the screen is giving off some light that can mess with your night vision and also disturb fireflies. So if you turn the brightness down as much as possible, that can help. Or you may decide that the trade-off is not worth it and you want to go with a separate voice recorder and stopwatch. Finally, a reflective safety vest is a really great item to at least have with you. And I'll talk a little bit more about this item under the survey safety section of this presentation. So before just heading out into the field, it's really important to take some time to do some planning. As a participant in the Firefly Atlas, you need to read, familiarize yourself with and follow the Xerces Society's Community Science Program Code of Conduct. And you can find this under the Survey Safety page under the Get Involved tab on the Firefly Atlas website. A really important aspect of this code of conduct is that you should always have written explicit permission from the landowner before you go onto a site, before you're present at night, and before you catch and handle fireflies. It's important to note that some places that are totally open to the public during the day are not open to the public after sunset. And this is the case in many places, and one of the reasons why it's super important to get permission from the landowner. Another good reason to reach out to the landowner is that they can advise you on what permits you might need, particularly if the landowner is public land or conservation land. The permits you need to catch fireflies will vary from state to state and by land agency. So the land manager can be a good resource to you to figure that out well in advance. And it also gives you the chance to answer any questions the land manager might have. You may put lightning bugs on the land manager's radar in a really novel and fruitful way. So either concurrently or after getting permission from the landowner, take some time to really look at the site on maps. Google Maps and the satellite view on Google Maps is a great place to start. You may also find trail maps created by the management agency or organization themselves. And you're really looking for two things here. Where is the promising habitat or the potential habitat? And what are the roads or trails or other means of accessing those habitats? And then we highly recommend that you visit the site during the daytime. And that gives you the chance to look at the habitats up close and see whether things that look good on the satellite maps are still look good on the ground. And also to look around for hazards. You really want to know where that big patch of poison ivy is, or those very thorny brambles. You want to know where those are before being there after dark and maybe running around in them. Making a visit during the daytime is also a great opportunity to figure out some logistical things like where can you safely park, and are there any gates that are going to be closed after dark. An important thing to look up ahead of time is what time is sunset going to be, and that will just give you a sense of what time do you need to arrive by and how much time do you need to budget for traveling to the site, especially if you're driving to the survey site. So safety is the top priority during firefly surveys. As a nighttime outdoor activity, firefly surveys have risks that we want to manage and we want to minimize. So I'm going to give you a list of things that you can do to make your surveys as safe as possible. A really big one is to survey in pairs or groups. Not only is this more safe, but it's also often more fun and effective. You have more eyes looking around for fireflies, more hands to share the data collection or scribing, and you can just cover a little more area. I'm just going to reiterate this one. I just shared it on the last slide, but visiting your site in the daylight is a really great safety precaution for many reasons. So if you're able to visit the site during the daytime, absolutely do so. Let someone know where you're going and what time you expect to be back, and maybe make a plan for what they should do if you haven't returned or you haven't sent them a text or called them as you exit once you have finished your survey. Carry a backup flashlight and batteries, just in case you drop or lose your headlamp. You'll still be able to navigate back to your car or back to safety. You want to wear appropriate clothing, footwear, and insect protection. And while we don't suggest that you actively apply bug spray out in the field, it is important to take precautions against ticks and mosquitoes and other biting critters and the diseases that those critters might be able to transmit. So I highly recommend long sleeves as much as possible, and sturdy footwear. Sometimes rubber boots can be, if you're comfortable walking in them, rubber boots can be great because many of our firefly species are in wetlands. And using a reflective safety vest, I highly recommend. There are two things that does. One, it makes you more visible to drivers of vehicles. If you're anywhere near a road, this is just a really good safety precaution. And the other thing that it does is makes you more visible to people who might be in the area and might be a little startled by encountering someone they're not expecting to encounter. So I'm a big proponent of using a safety vest. There are some places where it's absolutely essential and some places where it may be more of a judgment call. If you drove to your site, or if you had a hike to your survey site, really check in with yourself on how tired you are and give yourself enough time to drive home safely or hike out safely without being utterly exhausted. Sometimes that means leaving the survey site earlier than you would really like to, but driving at night can be one of the riskiest parts of firefly surveys. So monitoring your fatigue and reserving energy for your drive home is really important. Finally, if something or someone makes you feel unsafe or threatened during a firefly survey, leave as quickly as you can, and get help if you need it. Call for help if you need it. So what I'm gonna do going forward is basically show you the data sheet and the kind of steps that correspond to each part of the data sheet. So getting the data sheets involves going to the Get Involved tab on the Firefly Atlas website. That's fireflyatlas.org. And then under that Get Involved tab, there's a page that's Survey Data Sheets. There are 3 different data sheets whose PDFs you can download. There's one for nocturnal flashing fireflies. There's one for daytime dark fireflies, species like the winter firefly or the little diurnal fireflies that don't have lanterns and you might find at flowers during the daytime. And then a data sheet for glowworm fireflies. These are the fireflies in which the females are flightless and they glow from the ground at night, while the males, which may or may not produce light, fly around looking for these females. All three data sheets are very similar, but the flashing Firefly data sheet is the most complex. So that's the one that we're going to use as an example today. If you can follow everything on the flashing Firefly data sheet, you'll be fine with the diurnal and glowworm data sheets. Each data sheet when you print it out, it will be a single sheet of paper with 2 sides or 2 pages. And the front side is for information about things like who surveyed, where they surveyed, when they surveyed, what the weather was like, what species they were looking for. This is all information that you would collect regardless of whether or not you're able to detect and document fireflies. A bunch of this information you might describe as effort information. So it tells us kind of how hard you looked for fireflies, how much effort you put in to surveying. Now the back side of the data sheet is for the actual firefly observations once you find and document fireflies. So this is information that's specifically about the firefly that you're documenting. A single survey might have multiple firefly observations, especially if you find different types of fireflies flashing. You don't need to fill out a separate observation for each individual firefly that you see, but if you see more than one species, or what you think is more than one species, you can use a different observation section for each of those species. So you can print out either extra second pages of that data sheet, or just use that backside of an extra data sheet. So I'm going to walk through the steps of an imaginary firefly survey now, but I'm going to use images and video and some data from actual surveys. So our surveyor today is Laura Lightningbug. And Laura Lightningbug is following she's following best safety practices. So she's invited a friend to go with her. That friend is Freddie Firefly. He's an additional observer, and she is the primary observer because she has the Firefly Atlas account, and she's going to be the one entering the data. The number of observers is 2. They fill in the date, and if your survey spills past midnight, you can still just use the date of when the survey started. For site name, you want to use a name that is both specific and standardized if possible. So you want a name that in 20 years from now, someone would be able to locate on a map, or just know where you were talking about. If you have privacy concerns, like this was your backyard and maybe you don't want to share that, just use something that's accurate, but maybe a little more general. So you could use maybe your street name or the name of your neighborhood. In addition to the name, you'll collect and enter the geographic coordinates. So you notice a couple things here. One is that we use decimal degrees. So we don't use minutes or seconds, just degrees and decimal places. And 5 decimal places is a good amount of precision. So try to write down at least 5 numbers after the decimal point. You should also note that if you're in North America, which I imagine all of you surveying are, your longitude should always be negative because we're in the Western Hemisphere. There's a box for location precision. And this we collect because it signals to researchers who are using these data whether your point on the map would be appropriate to use for certain types of analyses, like species distribution models. So if your coordinates, if you're confident that your coordinates are where you actually were, and that there's a high degree of accuracy and precision there, you can use the smallest numbers, so 0 to 25 meters, meaning that if someone navigated to those coordinates, they would be within 25 meters of where you actually were. If, for example, there wasn't a good GPS signal, or there was maybe a dense canopy and you weren't able to really pinpoint on a map exactly where you were, you may need to use a higher number, say like 251 to 500 meters. Elevation is something that you'll probably fill out actually after the survey, but I'm going to talk about it here because it's in this section. There's a nifty tool on the US Geological Survey map viewer called the spot elevation tool. So you can click on a point and it will return the elevation, and you want to select the one in meters. I know that's not how we typically talk about elevation in the United States, but when we share, when these data go into databases, it's good for them to be standardized internationally. Approximate area searched is something that we're going to skip over for now, because at the beginning of the survey, you may not actually be able to answer this question because you haven't done all your searching yet. So we'll skip over to the target species. And this is maybe something that a space that you leave blank. If you are just heading out into a habitat and you don't really know, maybe you have an idea of what species might be there, but you're not specifically out to search for one in particular, you can leave it blank. If you are surveying for a Firefly Atlas focal species, and we hope that many of you watching this video are, you can enter that here. You can also choose a species that's not a Firefly Atlas focal species, but one that you think is going to be displaying at this time of year based on your research about the species, and you go and search in the habitat where you expect to see the species. You can enter that as a target species here. Basically, this is so that if you do not find the species of firefly, we can, for example, look for all the surveys that were targeting Loopy 5 firefly and see how many successfully detected the species and how many did not detect the species. Once you're ready to start surveying, enter the survey start time. You may use AM, PM, I mean, it's probably going to be PM, or you can use 24-hour time. Just be consistent and understand it for yourself when you enter the data. And when you start the survey is a really great time to take your first air temperature. So the next slide is moving on to the weather and moonlight section. So the weather conditions and the moon conditions can both affect the behavior and the detectability of fireflies. So it's important to record details about what's going on with the weather and what's going on with the moon. You can write down the sunset time before the survey. Again, this is a piece of information that is important for planning your survey. And that will then let you look and say, okay, not just did a firefly start flashing at X time, you can also say it started flashing X minutes after sunset. We have 3 broad categories for moonlight. You would check none if the moon has not risen, or it's a new moon, it hasn't risen above the horizon during your survey, or it's in the new moon phase. You would check bright if the moon, you can see a really crisp shadow because of the moonlight. You can practically see color. The moon is so bright. Anything kind of above a quarter moon is likely to be bright. And check partial if maybe there's a crescent moon, or the topography or tree canopy is only allowing a little bit of moonlight or some moonlight to reach the habitat. This is all a little bit subjective, so don't overthink it. Don't overthink it too much. Just use your judgment. You'll keep looking up for a little bit, and you'll enter the cloud cover. So there are 5 categories of how much of the sky is covered by clouds. In this survey by Laura Lightningbug, it's partly cloudy, so 41 to 60% covered by clouds. The datasheet uses the Beaufort wind scale for the wind speed, and that lets us choose between, if you have access to the actual measured wind speed, maybe with a device in the field or a nearby weather station, you can actually use the miles per hour that it's blowing to select a wind scale category, or you can use the non-measured indicators, like what the leaves are doing in the trees, or what a flag is doing up on a flagpole, to determine the wind speed. And if it's really windy, you're unlikely to see much firefly activity, which is why the options only go up to 5. The precipitation question is just trying to get at, is it actively raining? Has it rained recently, or is it dry? And the way we determine if it's rained recently is just, is the ground wet from recent rain? And that may be a little tricky to tell if there's like dew in grass, or maybe you're standing in a wetland, but just do your best and don't overthink it too much here. There's a question about humidity, and I imagine that most of you will not have a device to measure actually measure the humidity in the field or on site. That's totally fine. You can use a weather app or website, and that'll give you data from the closest weather station, using the current data. In the case of temperature, there's a sort of an array of options that you can use. Ideally, you'd have a thermometer to take air temperature in the field with you, and this could be something as sophisticated or involved as a Kestrel weather meter, which is the red thing in the photo here, or it could be something really basic that you buy at the grocery store, like this cooking thermometer on the right in the photo. And you can see in the photo that they're actually reading very similar temperatures. I think they're off by just 1/10 of a degree Fahrenheit. So it does ask for the temperature, the air temperature in Fahrenheit. You want to hold the thermometer a little ways from your body, or maybe even like hang it on a tree branch. Give it a little bit of time to stabilize before you take the temperature reading. You'll notice that there's also a space for the temperature at the end of the survey, but again, when you're going through the data sheet, you will not actually fill it out in this kind of linear order. You're going to come back to sections that you may have partially filled out, but not entirely filled out. The next section of the data sheet is about artificial light, also known as light pollution. So there are just some categories and spaces for types, sources, and notes. We're going to look at an example here. So this is a photo from a state park in Florida that's showing multiple types and sources of light pollution. At the top in the sky, we have sky glow, which is the yellowish haze from light reflecting up into the air. It's most obvious in cities, but we unfortunately will find sky glow even in rural areas. In this photo, we also have light trespass, and light trespass is light that is hitting surfaces beyond the intended target of the light. So that might be the ground, or it might be vegetation. In this case, it is both, and it's coming from outdoor lighting from a building, outdoor lighting on a building that's just to the right of the frame. And then over by this boat storage area, we have glare, and it's coming from a security light. So glare is direct, visually uncomfortable light. Glare and light trespass will often go hand in hand. The same source will produce both types of artificial light at night. So here, Laura Lightning Bug would fill out sky glow, light trespass, and glare. And the sources, she circles buildings, and then there's a space for other, where she writes security lights. And then there's space for notes, where you might give a little more detail or nuance to how artificial light is affecting or touching the actual firefly habitat. The next section of the front side of the data sheet is about habitat. So there are some options to choose from. And Laura Lightning Bug's habitat looks like this. It's an open area with mucky soils and wetland plants. It's really great practice to take photos of your habitat because chances are you're not going to write down everything that a photo can later convey. So you can look at your photo later and actually maybe identify some plants or notice things that you didn't even notice in the field. So here, Laura Lightning Bug has a habitat type that fits pretty well. That's open freshwater wetland. And you might actually find it frustrating if your survey site doesn't neatly fit into just one of these types. And that's okay. Just select the one that's the best fit, that you think is the best fit, and then give us lots of detail in the habitat notes. So if you have a technical name for this type of habitat, maybe a natural community type, you can share that here. You can give us a list of plant species, the dominant plant species. And if your habitat is actually several habitats because you have, for example, edge and transition, you can also make a note of that here. So Laura Lightning Bug writes, this is an open beaver wetland. So it's created by beavers along a small stream. and there's red maple, willow, jewelweed, cattails, broadleaf arrowhead, grasses, and sedges. So she's really painted a picture of the habitat that goes beyond these general categories. The next section is about how this habitat is being managed. So there's a list of management practices or activities, and then you need to circle yes, no, or suspect for whether you have evidence of or knowledge of these activities taking place. So in a lot of cases, you might just not know. For example, it might be hard to know whether there's insecticide or fungicide use in the habitat, because that probably happens during a brief period, and then you're not necessarily there to witness it. So circling no doesn't mean that it's definitely not happening. It just means that you're not able to provide any evidence that it is happening. In some cases, you may have some indirect evidence that management practice or activity is happening. For example, Laura lightning bug knows that this wetland has invasive plant species that are being controlled by the manager. So she suspects that herbicides are being applied in the habitat, but she doesn't know this for certain. And then in some cases, it's pretty apparent that an activity is happening in the habitat, like mowing. There's short grass, and maybe there's even signage about how the habitat is managed. Firefly Atlas surveys aren't designed to do a rigorous study of the effects of different management practices on fireflies, but this is still helpful information to know, and may help guide future research that digs in a little more deeply. So we've reached the end, the last section of the front of the data sheet, all the event information. And that's the last section is just a space for general notes. You can really do whatever you want with this space. But a few things that might be nice to put here include if there's weather variation, like maybe the weather that you write down at the beginning, or even the primary weather conditions that you write down. Maybe it doesn't capture the rainstorm that rolled through, or a moment when the wind really shifted. You might also talk about other wildlife. It might be nice to know, for example, that fireflies are flashing when a particular type of amphibian is calling, maybe a frog that's calling. It's a good space to talk about factors, other factors that might influence firefly detectability. For example, dense fog or really dense vegetation. And then finally, if you cover if you walk a good distance during the survey, it might be nice to include a little more detail about kind of where you started, where you went, the names of the trails that you walked on, things like that. At the end of the survey, be sure that you record the end time. It sounds obvious, but it's actually very easy to leave this blank when you are maybe tired and ready to get home, and you're done looking at fireflies. Make sure that you record this end time and also the final temperature. And then once you're home, or maybe the next day, or not too long after your survey, is a good time to estimate the area that you surveyed. And we do this in hectares. So what the heck is a hectare, you ask? Why are we not using acres, which is a more familiar unit of area for those of us in the US? So a hectare is a metric unit of area. It's a little bit less than 2.5 acres, and it's if it's as a square, it would be 100 meters by 100 meters. A kilometer-long transect where you were searching 5 meters on one side of you and 5 meters on the other side of you would also be one hectare. So it's 10,000 square meters. And we use hectares partly because it's a unit that's used all across the world in science, but mostly I like to use hectares because it makes the math a lot easier. So I'm going to show you an example with using Google Maps to estimate the area that you searched. And you'll see how hectares is helpful. So if you go to Google Maps and you right-click on a point, it'll bring up the tool, the option of the tool measure distance, and you can click kind of along the outline of an area, or if you're just measuring a distance along a line, and that will give you either the distance and the area. So here I'm Laura Lightningbug. This is kind of switched survey sites, but now she's in a salt marsh, and she traces a polygon, a shape of where she was able to search for fireflies, and that number is a little less than 30,000 square meters. So if you divide that by 10,000, or just move the decimal point 4 spaces to the left, that will give you the hectares. So the area searched here is 2.97 hectares, approximately. You can enter that on the data sheet. And now Laura Lightningbug has filled out the entire front side of the data sheet with lots of information about this survey and the effort that she and Freddie Firefly put into their search. But what about the actual fireflies? I think that's what many of you are actually watching this video to learn about, is how to observe and collect data on the fireflies themselves. So in this next part of the video, I'm going to show you how to search for fireflies and how to document fireflies on the observation side of the data sheet. So here's some tips for surveying for fireflies. Some of them are more obvious than others. So keep your lights off to the extent that is safe and practical. This will disturb the fireflies less. It will keep your night vision nice and sharp, and let you spot flashes at a further distance. Obviously, you may need a little bit of light to navigate or find something in your backpack at some point. And when you do that, just be sure to use dim red light. So this is where your red filtered headlamp comes in, or your flashlight with some red cellophane. And really just try and keep it as dim as possible, as dim as you can with the thing that you're trying to do. You want to visually scan the habitat, looking for flashes and glows. So pretty obvious, but the way that you're going to find fireflies is with your eyes. But our eyes can trick us. So don't be confused by the following things. And I either have been tricked by these things, or I know of other people being tricked by these things. So insects flying under street lamps can sometimes look like fireflies. Decorative outdoor LED displays that are actually designed to look like fireflies have tricked more than one person that I know. So particularly if you're near houses, you know, keep in the back of your mind that there may be laser light shows that look an awful lot like fireflies. And even just light, like it could be moonlight reflecting off of leaves, can look like a passing flash or glow. So give things a second look, and you know, trust your eyes, but verify. And then finally, while you're searching, it's really good practice to just every so often make a note of where you are and what time it is. And you can, using a voice recorder is a really good way to do this. You can just kind of say, it's 9 p.m., I'm on such and such trail. And you know, if you haven't seen fireflies yet, you can say that. If you have, or they're continuing to flash, you can also say that. So Laura Lightning Bug finally sees some fireflies blinking. What now? So Laura Lightning Bug will want to make a note of the time and the temperature. We want to get that information, but then take a little bit of time to simply observe and take it in, and just kind of see what you notice. So I'm going to play a 12-second video of a firefly displaying. It's taken maybe around 9:15 p.m. and the air temperature is 78 degrees Fahrenheit. The flashes are going to start in the middle of the frame, and then they're going to move higher up against the paler sky. So here goes. What you just observed was a male firefly giving its flash pattern twice. The next part of the data sheet is all about firefly flash patterns. So I want to make sure that we're all on the same page about what a flash pattern is, what are its parts, and how you can use time measurements to characterize the flash pattern of a species. When we talk about flash patterns, we're generally referring to the species-specific light emissions, so the blinks and flashes that form the courtship display of male fireflies. So fireflies emit other types of flashes, like when females respond to male courtship flashes, or when a female photourus firefly mimics other fireflies. And also, when you catch a firefly, they'll sometimes give alarm flashes. But the male courtship flash pattern tends to be the most consistent and useful flash behavior to use for species identification. So in this photo, this is a beautiful image taken by Radim Schreiber of fireflyexperience.org. We see the male flash pattern of a cypress firefly, Photourus waldoxii. And if we watch this and transcribed it onto a chart where time is going left to right, you would see something like this. So we have 5 quick and brief flashes, followed by a longer glow that lasts about a second. And this whole flash pattern is happening over 3 seconds. That's how long it's taking to fill the, to do the whole flash pattern. This is a complex flash pattern, so the basic unit is made up of multiple flashes, but in many cases, you'll have a simple flash pattern. So here's another example. This time it's an image of Big Dipper fireflies in Kentucky. This image was created by John Abrams and uploaded to iNaturalist. It's an awesome image. And you'll see long upward rising flashes that are repeated about every 6 seconds. So the flash pattern chart would look something like this. So single flash rising in vertical space, repeated every 6 seconds or so. On the bottom of the back of the data sheet, there are diagrams showing examples of flash patterns and the time measurements that can be used to describe them. So it's almost a little bit like reading the rhythm of sheet music. So each black dot is a pulse of light, and the space between those dots is just time when it's not flashing. So flash duration, which is the length of time that the actual flash is lasting, and flash interval, which is the time, basically that dark time in between flashes, is sometimes really brief and hard to measure in the field. Often the best or easiest flash pattern measurement to take is the flash period. So that's the time between the beginning of the flash pattern and when that flash pattern is repeated a second time or a future time. So even though you might not be able to measure the flash interval or the flash duration, you can still use verbal descriptions to give a kind of paint a picture of what that's like. So you can use things like, use words like quick, brief, or less than half a second. So I'm going to revisit the same video of the firefly flashing, and I'm going to narrate as we watch it. I'm going to count aloud as if I was speaking into a voice recorder. And ideally, I would have said right before doing this, I would say the location, the date, and the time. So here goes. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you can see that that takes a lot of focus and is not a precision instrument, but particularly with complex flash patterns, it can work better than using a stopwatch. So if I had to transcribe this flash pattern that I just recorded, it might look something like this. So you can see that the flash pattern consists of 5 quick flashes that are emitted over about 2.5 seconds. And the flash pattern period is about 6 seconds. So it starts at the 3-second mark and then is repeated at the 9-second mark. So we've already kind of gathered a bunch of this information. So let's put it on the data sheet with Laura Lightningbug. We see the first flash at 8:45 p.m. The air temperature is 75 degrees Fahrenheit. You wouldn't find this until the end of the survey, but you'll write down the time of the last observed flash as well. This isn't necessarily when they stop flashing for the night, especially if they're still flashing up until the end of the survey. But it's just, again, the last flash that you were able to see. Again, this is why it's a good idea to just periodically kind of keep a log of times and whether they are still flashing or not. Within the flash pattern, there were more than 4 flashes. What we saw was 5 flashes. So we'll check that box. And the next question is about flash color. And our perception of the color of Firefly flashes is subjective and can be influenced by our age or the humidity in the air. Oftentimes the color seems to either be yellowish green or greenish yellow, which is not a particularly neat category to put on the data sheet. That said, when you see flashes up close, you can notice some distinct differences in color. At dusk, it's more common to see yellow flashes, especially from fireflies in the genus Photinus. Once it's dark, flashes tend to be more green, and Photurus fireflies tend to fall in this category. If you see orange flashes, you're likely seeing fireflies in the genus Pyractomina. This photo, which was taken by John Manchester at Congaree National Park, is a candle firefly or Pyractomina angulata. So it was hard to see in the video, but Laura Lightningbug makes the judgment call that the flash color is green and doesn't overthink it. From the voice recording that she takes and maybe stopwatch measurements as well, she notes that the flash pattern period is 6 seconds. The flash duration is too quick to actually measure, but it's definitely less than half of a second. And same with the flash interval. The height at which the males are displaying, you can select more than one zone. So for this firefly, it was the low and moderate heights, so 0 to 8 feet. And we'll also enter just a narrative description of where those flashes were. So they're out in the open over a marshy area. We'll also enter just a verbal description of the male flash behavior. So Laura writes, about 5 flashes emitted erratically in a tight space while flying up and down. There seems to be some variability in flash duration and flash interval. And you saw that some of those flashes at the end of the flash pattern were kind of a longer glow, almost like that cypress firefly flash pattern photo. You may or may not see or identify females, but if you do see females flashing, you can put down their flash behavior. So Laura Lightningbug writes, a few females were flashing at irregular intervals while perched in the tall grass. So once you've carefully watched the flash patterns and recorded flash pattern details, it's time to catch a firefly. So ideally, you would catch the very same individual whose flash patterns you just observed and measured. But this can be quite challenging. So at the very least, you should catch a firefly that's giving the same flash pattern as the firefly that you observed. If the flash pattern is 5 quick blinks, and you really took measurements from a firefly doing that, catch another firefly that you see doing a similar flash pattern. Maybe you don't actually pull out your stopwatch, but it appears to be the same thing. This is especially important in times of year and in areas where you have multiple types of fireflies displaying. So catching fireflies in the dark with your net is going to take some practice. So don't get discouraged if you have swing and a miss for your first few attempts. You want to swing the net horizontally, generally, and you want to follow through. So you're getting the firefly into the tip of the tip of the net, and then give that net a little flip or kind of rotate it 180 degrees or 90 degrees so that the firefly can't just crawl straight out. Then you want to reach in with your petri dish or your vial and get the firefly out of the net. It's easy to lose a firefly at this stage or for it to escape. So take your time. And this is one of those moments where it might actually be helpful to use a little bit more light. Once you have your firefly in your clear container, take photos from up close as your camera is able. And you want to get photos of the back or a dorsal photo of the upper side and of the underside or a ventral view. That ventral view is going to show us the lanterns or the light organs. And it's also going to confirm that the firefly that you captured is a male, or maybe you catch a female, and we'll be able to tell from the arrangement of the lanterns. When you take your photos, showing the size of the firefly is really helpful. So you can use a measured graph paper that you put inside your petri dish, or maybe you put your petri dish on top of this graph paper. You can also put your firefly gently in a clear plastic bag and then carefully kind of press it up against a ruler while taking a photo or taking a measurement. And the back of the data sheet actually has in the lower right, it has some millimeter marks that should be to scale as long as you print on 8.5 by 11 paper. When you take a bunch of photos, over the course of a night, you want to make sure that you can connect each of those photos to the flash pattern details that you recorded. So you can, on the data sheet, you can enter either the image number, which your camera will record, or the time associated of when you took that photo. This section of the observation side is actually above the flash pattern details, but it makes sense to do after the flash pattern details. So for each firefly observation, you should make your best guess at the species that it was, and maybe all you're able to determine is the genus. That's still great. You want to estimate how many individuals you saw, and this is really kind of broad general categories. Fireflies are really hard to count accurately, so do try and give us the best estimate you can, but counting number of individuals again is really hard, which is why we have those broad categories. And then there's also a space for additional notes that are not related to the flash pattern. So you could write down maybe the size or some other aspect of its behavior. Again, once you have filled out the event information, you have collected flash pattern details, and you have taken a photo of the firefly, and you're ready to go home, make sure you record the end time and the air temperature at the end time. So Laura Lightningbug has wrapped up her survey. She's made it home safely, which is an important part of the survey process. She's sorted through her photos, and she's used online resources to fill out things like the area searched and the elevation of the site. Now it's time to enter the data to the Firefly Atlas website. So to do this, make sure you're logged into your account, and then you will click on Record a Sighting, which is at the top of the page. And just like the data sheets have an event section and an observation section, you might think of the event section as sort of the effort section, and the observation section as the actual, that's where the Firefly is. The data entry portal similarly has two forms. The first digital form that you're presented with is about the survey or the event. The name of it when you save it will be an event survey. So you'll fill this out regardless of whether or not you found fireflies. But every firefly observation is going to be linked to an event survey. So you'll fill out lots of things that are directly on your data sheet, and you'll also answer a couple of questions that are not on the data sheet, like whether this is a sensitive location or not. So if you respond yes to this sensitive location question, this observation will not be displayed precisely on the map. So it'll be a generalized location that's not, say, showing where your backyard is. There's also a question for what state or province you're in, which is not something that's on the paper data sheet. So after you've filled out this information, at the bottom, make sure you click on Save Event Survey. And if you documented fireflies and you're wanting to submit observations, you're not done yet. So you save your event survey, and this will bring up a green box that says, thank you for your submission. And there will be another green box that says add observation. And this will pull up the observation form. So basically all the questions from the backside of the data sheet. And you can upload your photos, fill in flash pattern details, and enter other firefly information, including what your sort of preliminary species identification is. If you're not sure what species it is, you can enter unknown in the genus and species fields. Or if you know the genus but not the species, you can fill that in and just put unknown in the species field. The very jump back here. Make sure at the bottom of the page to click Save Observation. May say Save Firefly Observation, but make sure you click that, and that will save your observation, which will be connected to your event survey. So that's great. You've entered your data. What if you need to edit it for some reason? Maybe you realize you have a better photo that you'd like to swap out, or you have new information, or just realize that you made a mistake. You click on Profile. Again, make sure you're logged in, and click on Profile at the top of the page. And on your profile page, there are going to be a couple sections. One is a list of my surveys. And you'll notice on the left that you can click on Edit Survey. That will reopen the digital form, and you can make whatever changes you want to the effort information. There's also a list of all your Firefly observations. And notice on the left that each observation is linked to an event survey. So either, and we say event because it could be a survey, or this could be an incidental encounter with a firefly where you were able to document it, but you didn't have like the area that you searched, and there wasn't a beginning and an end time. So actually in the event section, of the data portal, there's a question that asks, is this a Firefly survey or an incidental observation? So if you have a data sheet that is entirely filled out, that's a survey. And if you just have, say, a photo of a firefly on your phone, it's going to be an incidental observation. So once your observations have been submitted, a Firefly Atlas coordinator, like myself, will verify the species identification, either confirming it by changing the status from unreviewed to verified, or by editing the observation to have the correct species and then verifying it, or changing the status to verified. On the observation pages, there's also the ability to leave a comment. So the coordinators may make a comment on your observation, maybe just thanking you, or maybe asking for some more details about a particular aspect of the observation. Well, the Firefly Atlas survey protocol has a bunch of key elements, things like air temperature and the effort information. Every Firefly expert I know has a slightly different approach to Firefly surveys. Some surveyors may want to take a lot of video and then later examine that video more closely. Others have a strong preference for voice recordings and maybe even using sound software to look at sort of wave diagrams of those voice recordings. On some surveys, it might make most sense to stay in one place for the entire evening. And in other cases, you might walk more than 1 kilometer, covering area and checking out different parts of the habitat. Ultimately, it's going to be up to you to figure out your preferred methods and approaches. And this will depend largely on what equipment is available to you, what species you have in your area, and what your habitats are like. If you discover a Firefly surveying technique that you really like and want to share it with others, we'd love to hear from you. And I think there's a lot of room for innovation because the truth is that not that many people are really diligently watching fireflies still. Before I end this video, I'd just like to make a special thanks to any Xerces Society members who are watching. Our work is not possible without your support, and we just really appreciate that you let us do this work of protecting insects, and specifically fireflies. If you're not a Xerces member, you can go to xerces.org/donate, and we would love to have you join us. So we're at the end of the video. Thank you for your interest in conducting Firefly Atlas surveys. There's still so much to learn about the firefly species in North America, where they're found, when they're found, and your time, curiosity, and observations, both of what you find and what you don't find, will help us to both understand and protect these marvelous insects. So if you have any follow-up questions, I'd love to hear from you. You can email me at fireflyatlas@xerces.org. Thanks for watching, and happy firefly watching.